All right, so lesson number 3, percent yield calculations using gravimetric examples. You should have had a little bit of experience with this already in the labs we have done, so it should be more of a review. We are going to do both percent yield and percent difference. Percent yield is the actual yield divided by the predicted yield times by 100%. This actual yield is from the experiment, so it will be the amount of product we actually collect. What is the predicted yield? Well, that is the yield we would have expected from our stoichiometric calculation. All right, so we have our actual yield from our experiment, what we actually got, divided by what we predicted we would have got. Think about this like your test. Your actual score might have been 48 out of 50. Now, you predicted you would get 50 out of 50 because you're an IB student, and unfortunately, you made a couple silly errors. You got 48 out of 50. What was your percent yield or percent on the score? 48 out of 50 times by 100% gives you 96%. Shame. Just kidding. Moving forward, we're going to use talking about percent difference. Percent difference is the actual yield minus the predicted yield divided by the predicted yield. We do not use absolute values in IB because we want to see if our percent difference is negative or positive. If our actual yield is less than our predicted yield, then we will have a negative percent difference. If this was, let's say, 50 grams and our predicted yield was 60 grams divided by 60 grams, it would give me 50 minus 60 divided by 60, which is negative 16.7%. This tells me that I have less than what I expected. If we were actually to get the other way around, where we got 70 minus 60 divided by 60, now I have a positive percent difference, which is positive 16.7%, and it tells me I am over my predicted value. So in IB, we do like to keep the positive and negative symbol. Negative means we didn't collect enough. Positive means we collected more than we expected. Here's our first example. Slaked lime is produced when water reacts with quicklime, calcium oxide. If you start with 2,400 grams of quicklime and add excess water to produce 2,060 grams of slaked lime, what is the percent yield for the reaction? So here is my given information, the 2,400 grams of quicklime that is given. Now, what about this information here? To produce 2,060 grams of slaked lime. Is that my wanted? Is that my actual value? Is that my predicted value? Well, if we use 2,400 grams of quicklime, how much should we have produced? Let's do the stoich and figure it out. First, the balanced chemical equation. Calcium oxide, CaO, solid, plus water, liquid, is going to produce calcium hydroxide, which is also a solid. Now, when we do this, it's already balanced. We have one calcium. We have two oxygens, and we have two oxygens, and I have two hydrogens, and I have two hydrogens. So we have a balanced chemical equation. The mole ratio is 1 to 1 to 1, which makes life a little bit easier. Now that we have our chemical equation, our given information is that mass of our quicklime, which is equal to 2,400 grams, molar mass, which we calculate, and we find to be 56.08 grams per mole. Mass of our product is what we're looking for, and we're looking for the predicted mass of our product. We have our molar mass of our product, which is 74.10 grams per mole. Following through on the stoich, starting with our mass, our measured amount, of our given 2,400 grams of CaO, multiply by something to get rid of the grams of CaO and replace with moles of CaO. Our 56.08 molar mass, grams per 1 mole. Multiply by the mole ratio. Still have to show the step even though it's a 1-to-1 mole ratio. 1 mole of CaO on the bottom and CaOH2 on the top. And then we're going to multiply by the molar mass of calcium hydroxide so we can get to mass of calcium hydroxide. So on the top we have 74.10 grams of CaOH2, and on the bottom we have 1 mole of CaOH2. Notice how as we move through we have grams of calcium oxide cancel, then we have moles of calcium oxide cancel, then we have moles of calcium hydroxide cancel, and we're left with grams of calcium hydroxide. Completing the calculation, you should find that you get 3,171 grams of calcium hydroxide. This is my predicted amount. Predicted comes from the stoichiometry. Now, what is the percent yield of this reaction? Percent yield is equal to actual, 2,060 grams, divided by predicted, 3,171 grams, times by 100%, which is actually a percent yield of 64.96%. If we wanted to determine the percent difference, we would say percent difference is equal to actual minus predicted, which is 2060 grams minus 3171 grams divided by 3171 grams times by 100%, and that would be equal to negative 35.04%. I have one more for you to try. Pause the video, think about this question. It's kind of tough to work your way through, so have a good think and take your time, and then continue the video and you'll see the solution and see if you can match my solution. The tricky part to wrap your head around possibly is viewed over here, where we have our actual mass that we need to produce is 700 grams. So what would our predicted mass have been if we have that 70% yield? So then we have to work backwards to figure out what the predicted mass is. Once you have the predicted mass, the stoich is pretty straightforward, and you can see that over here, which leads us to get 822 grams of nitrogen is needed to produce that 700 grams of ammonia, even though theoretically, or our predicted value was actually 1,000 grams of ammonia. There are a few practice questions in your workbook on percent yield and percent difference. Questions 41 to 44, give those a shot.